Hey everyone, Dimitri is here back with another episode of Data Protection Gumbo. And I have a great guest lined up for us today, Mike Bowers. And he is the chief architect over at Faircom. And I'm probably sure that you may not have heard of Faircom, but Mike, welcome to the Gumbo. How are you?
Oh, I'm doing great. Thank you, Demetrius, for having me on.
So, enlighten our guests on Faircom and also what your role is there.
Yeah, well, Faircom is a database vendor. We sell database software, and you may not have heard of us because we've sold to be our product to be embedded in other products. So we're embedded in all kinds of great products, millions of deployments around the world, and it's an invisible product, at least for the
Mm,
last 30 some years. And we're an engineering company, so we sell to engineers, and we haven't had much of a marketing team or a sales team until the last few years. And then we realized, well, that was probably a business mistake. Even though we're really highly successful, no one knows about us because we never got the word out. We're in major systems like the US stock market. We're tracking all the stocks that are being sold in real time and at
hmm
night. Our product, our database, it runs they our customers who manage all the stock market data. They run these huge batch jobs that calculate the analytics for the entire US stock market and deliver to all the stock market analysts the next day. And that's all done in real time and then overnight in batch jobs in our product. You got every flight in the US is
hmm
tracked in real time in the Faircom database. And so, and that's a pretty big deal because that's every flight in the US.
It is.
So the
Okay.
FAA does that, and then the actually in the space station and embedded in the space station running the space station, both US and European space station, packages being shipped. We have one of the major US carriers, they actually use us for managing all the shipments of their products. The
hmm
top number Intel, the number one manufacturer of semiconductor chips in the world
hmm
uses our product exclusively as the database to track all of their manufacturing. They have
Okay.
opportunities to use Oracle, SQL Server, because the software they're using has multiple vendors under the hood that can be their database, but they refuse to use any other database but our database because we're the most performant, the most consistently fast, and most reliable database. And my
Mm.
favorite is Commvault.
Mm.
Commvault is backup software.
Yep.
And
Know exactly what that is.
yeah, because you wear the data t-shirt, so you know
Yeah.
data.
Yeah. I've been in that space for quite some time. Currently with Veritas as well. So I know that space really well, and I could just hear and feel your excitement coming across the airwaves here. And I really want to tap your brain power just to understand because you threw out a lot of facts there. You talked about all these different transactions, right? So the database is obviously the heart of every company. And so take us down memory lane back from a perspective of, let's say, 10 years ago, right? And how technology has evolved where we didn't have quite as much data. Maybe companies weren't running billions of columns and rows, and they didn't have quite that much data. But today, obviously, we are well over that number, and it's almost impossible to track how much data is going in and out of that system. So, what's changed from your perspective, and how can the Gumbo listeners learn from that perspective, especially when it pertains to scaling a database?
Oh yeah. So we're the reason we have so much data is we have so many things producing data now.
Mm,
Just everything is becoming smart. So every device, in fact, I'm hooked up to this podcast on a smart audio video controller, and
hmm
it's tracking all this data about converting the audio and the video. And that information is not interesting to me personally, as long as it looks good to you guys. but
yeah.
but if I was a professional in the audio video world, it'd be really important to me to know the quality of the audio over time during a recording and that kind of thing. Everything is recording data about what's going on. In fact, every it's you have smart cities now. You have smart
Mhm.
hospitals, smart factories. They're all recording data. And we just built a new product called Faircom Edge that helps these smart cities and factories collect all that data so that they can use it for analytics and machine learning and artificial intelligence and to gain deeper insights into who the customers are, or how can we improve a manufacturing process, or how can we improve the traffic on a street, or how can we improve patient care in a hospital.
Mhm.
So this data is being put to use through very great, really cool things like machine learning and data warehouses that collect the data and do analytics to tell business how to do better business. So yeah, we have more sources of data than ever before. That's the problem. It's the Internet of Things. Everything's a thing.
Right. Right.
Everything can produce data. And my refrigerator produces data,
Mhm.
literally. So does my stove. And every door in my house, I have smart locks on the doors. I have a smart house, so I can
Yeah.
push a button on my phone and have lights come on, the music come on, close doors, lock doors, unlock doors because it's all smart devices. So the amount of data is huge.
Gotcha. So yeah, so data has increased and it's obviously not slowing down anytime soon. We have IoT devices are everywhere. Everything is tracking and accumulating data. But one issue though is really trying to tap into that data to get analytics in order to make informed decisions about what the future may hold so you can be more efficient as far as running your company or your organization. And we can't do a podcast without mentioning the secret buzzword of two letters, AI,
Oh
right?
yeah.
So, from an AI perspective, what does the future look like for databases and artificial intelligence, Mike?
Oh, I love that question because first off, AI is a broad category, and one aspect of AI is machine learning. And machine learning, the way it works, it's all statistics. I mean, I don't know if people know that, but it's advanced statistics. And what it does is you take a bunch of data in a database. So you
Mm,
start with data to make machine learning possible.
mhm,
And you train you curate the data. So you go through the data and you make sure that you get the data you want to have to train the machine learning. If you train machine learning with bad data, you get a bad training. And
mhm.
you've all heard the horror stories where they used public data and public interaction to train certain bots, and then they started swearing and started they were racial profiling and sexist, and they were horrible. And
Yeah.
then you're like, well, how come these bots are so evil? Well, because people were toying and playing with them and giving them bad data just to see how bad they can make the bot. Well, so
Mm.
you don't let people train things because we we have too much fun with that, I guess.
Yeah,
But
yeah.
you curate the data. So first you have to have data. You curate it, make it just the way you want it. You train the model, then you can deploy the model on trained data. And it's the way these hyperscalers are doing it with ChatGPT. They trained millions of models and put them all together in one gigantic machine learning system called ChatGPT or these others. And that it's all based on data first. So you have to collect the data, you have to curate the data, and to curate data means you have to have a database that can query the data to find the bad data and get rid of it, and classify the data and say, okay, this is not only good data, but this is for example, let's say if you're trying to do stoplight training data, you say this is red, yellow, green.
Mhm.
And you would say this stoplight is red. Well, you think, well, humans know it's red, but a machine doesn't know it's red. So you have to train it and say, here's all these pictures of stoplights that are red. Here's pictures that are green. Here's pictures that are yellow, in all kinds of conditions: stormy, rainy, snowy,
Yeah,
and windy.
right.
And then the machine learning algorithm goes, oh, okay, now I know what red, green, and yellow are. So that and then you put that in your car, and then the car could see the stoplight and say, oh, red, stop. And this stops your car. But you had to train that first. So you need databases that can query the data, identify the data, and then once you've trained it, you can do really cool things. So that's one part of AI. The other part is, even to me, even cooler. And this is what we call semantic learning or semantic databases, which is where you create these knowledge systems using a very simple concept. It's called a triple. It's a graph relationship. And those are all technical terms. What it means, they're really simple. It just means this is related to that. So you have three things. You have a this and a that and a relationship. And with
Okay.
that simple little item, this relates to that, you can build complex knowledge bases that say, well, Mike likes Demetrius, but Demetrius likes Mike. And Mike and Demetrius like this podcast, right? And then our listeners like this podcast. Therefore,
Mhm.
the listeners might like Demetrius and might like Mike. And so you can make inferences. That kind of database is called a graph database.
Okay. Yeah.
And Faircom is building the next generation graph database technology right now to work with our traditional database technologies. Like we have a SQL database that is used by all the data warehousing and machine learning algorithms. But this graph technology is being used by the cutting edge databases to do the next level of artificial intelligence. So that works hand in hand with machine learning, but it's different than machine learning because
Mm.
knowledge bases are human curated, not machine curated. So humans go in and say, Mike likes Demetrius. You can also write programs to go figure that stuff out and just populate the graph database. And but anyway, that's I worked. By the way, I
Okay.
worked with a medical doctor. He he spent 10 years building this graph database at a very famous clinic, and it was on diabetes. And he could prove that he tracked all his patients in the graph database, and he could diagnose them using the database with more accuracy than a experienced diabetic doctor could do it,
Hmm.
because he had put all of his knowledge of detecting all everything about diabetes into this graph database. And
Mhm.
then he extended the knowledge with 10 years of data from patients, and then validated that through the graph database and tuned it. And then he has basically an artificially intelligent doctor in that graph database that can diagnose patients better than human
Mm.
doctors.
That's scary too, right? Because
If they screw it up.
well, and look, we're talking security too. What if,
Oh yeah.
because now I want to talk APIs, right? So tapping into that data, tapping into that database and communicating with it, because you mentioned that companies use your database in order to track or help with maintaining lots of data, right? Columns and rows, pointers. This piece of data sits here. This customer first name is here. This last name is there. The social security number is here. All the different rows and columns, right, of a database. And I know it's more complicated than that, but just from an API perspective, how important is it to secure the APIs, especially when you're talking connecting to something as important as a database?
Oh, yes. In fact, we just finished a security audit here at Faircom. You didn't
Mm,
know that,
okay.
but we brought in a security company to go do that exact thing, go to all of our APIs and see where the vulnerabilities are. And then they find little things and we fix them. Luckily, we came out really well, and I'm happy because you never know. You go, oh my goodness, there could have been a major issue. But yeah, you have to secure the APIs because that's the way software talks to the database.
Mhm,
And you have to secure a database in a couple of ways. First, you have to make sure the APIs are not hackable, because
mhm.
bad guys love to stick weird binary data in your API and try to penetrate it with some strange payload. And if they can succeed, they can then take that payload, put it in your memory, and it becomes a program that they can do terrible things. So
Wow.
you have to make sure they can't penetrate your APIs.
I
So
is that a SQL injection or what?
that can SQL injection is one of them. There's other kinds of injections that can just actually take real programs and embed them in software. So you have to a
Wow.
really good database vendor has to protect against all those attacks so that you can say my data is safe. So the first line of defense is a really good database vendor who has security hardened their APIs. The second one is you have to use secure protocols to talk to the database. And that's what we use on the web. We use HTTPS,
Mhm.
or the technical name is transport layer security, or TLS. But anyway, it's a way to encrypt the data on the wire so that no one
Yep.
can see the data. So your database APIs have to talk TLS, or so that your data is encrypted and safe. The third thing you have to do is make sure your data is encrypted at rest in the storage. Because if a militia attacker got into the data center and pulled out a hard drive, took it home, and it's not encrypted, well, they could have terabytes of data in their hand that they could do
Yeah.
horrible things with. So you got to protect against that. And then so that you encrypt at rest, you encrypt in transit, and you make sure your APIs are impenetrable from attacks. And that's a
Mm.
lot of stuff you have to do to make it work.
Okay.
But
Yeah. And so TLS, I think where are we now? 1.2, 1.3 maybe?
1.3 is the
Okay.
brand new one.
Yeah, see, I haven't walked down that path in a while, and it's kind of FIFO for me, first in, first out, as far as what I keep in my head. But I do remember working on a project, and we were diving into upgrading or implementing the product to work with the new version of TLS, because there's a long list of things that you have to do to update your product in order to really to integrate with the newer version. And I know that's a super techie nerdy type of conversation,
Totally.
and we won't dive into that, but you mentioned keeping data encrypted at rest and also in flight also. And so maybe one final question here. What are you seeing as far as, and I am asking as many people as possible about this right now, because I keep hearing that the job market right now is in flux. It's changing. So the tech industry right now, there's a ton of people laid off post COVID because corporations are saying we overhired, right? And we're still shedding people because we overhired. We were very optimistic, and now we are laying off 5%, 10%, whatever the case may be. Now you have AI, OpenAI, ChatGPT, Perplexity, all these different AI platforms have now Pandora's box is opened, right? So little old people like you and me, we're using these bots, and we're using ChatGPT, et cetera, to do things more efficiently and help us write emails, and who knows what else we're using these things for, right? But what are you seeing? Are you hearing or seeing anything just on the job front? What are you reading, and where do you think the market is right now, and what advice do you have for someone who is actually in the market right now and looking?
Yeah, you're right. The industry overhired about 3 or 4 years ago. There was a big surge. Everybody just it was a land grab, and salaries for tech people went through the roof. It was great. And then of course there's the reality hits and people go, "Oh no, we overhired, we're overpaying," so they lay off. And that's a constant cycle. The In the tech world, the more technical skills you have and the more specialized your technical skill is, the more likely you can get a very well-paying job and keep your job. If you're the balance you have to have is specialization versus generalization. If you're
Okay.
highly specialized, like my son, I trained him to be specialized in a database technology. Yeah, I did.
Why did you choose database? No, I'm just kidding.
I wonder why. And so it's been really good for his career. He makes more money today than I made 10 years ago. And I've
Yeah,
been doing this
yeah.
for almost 40 years. So it's kind of like, wow. Well, I gave him a jump start. So I'm really happy about
Mhm,
that. But I'm
mhm.
also a little jealous, like, wow, I wish
Great
I was
job, dad, great job.
30 years old and making that kind of money, because I train him in a specialized database that is in demand enough, but it's rare enough skill that it's hard to find, and so you get a job and get a lot of money for that work. The risk is if people stop using that database technology, then he'd be out of a job because
Yeah,
so that's the generalization part. You need to make sure you have general skills so you can get a job easily and quickly, and the specialized skills so you get paid really well and keep your job a long time. As far as AI goes, taking over the work, I was at a conference recently talking to some thought leaders from Microsoft and a lot of big companies doing AI at the big level. And their comment was AI is kind of at the high school level. If you trust an AI answer about as much as you would trust a high school student's answer to your question. And so
mhm.
And I thought, that's a pretty good way to look at it because you want to
Okay.
really vet it. Maybe a college junior, but you get an answer from AI, you want to trust it, but you have to really verify it because it's not at a master's level or a PhD level. You
Hmm.
can't trust it as much as that. You really have to just use it as a jump start. And I do a lot of writing, so I use a product called Grammarly to check my
Oh yeah.
writing, and Grammarly drives me insane because there are certain things it's absolutely correct on, and I need to change my writing styles. But Grammarly tells me to do a lot of things that's just flat out wrong because I'm writing technical documentation and it doesn't understand what
Hmm.
I'm trying to do. And so it actually gives me more false positives, more it finds more things wrong that are not wrong. And it drives me crazy just saying
Mm.
dismiss, dismiss, dismiss. So but I have a tech writing team, and that tech writing team, they're smarter than that, and they know better. And so it's easier to
Yeah.
work with the tech writing team to update my stuff than using Grammarly. So Grammarly's AI based.
Yeah.
So over time, I think in the next 10 years, it'll move from being high school level to college level, and then who knows when, maybe even post college level, like master's and PhD level. At that point, tech people are going to have to worry about their jobs
Mm.
because they'll be competing with AI. But we're talking 10, 20 years probably.
So you're saying there's nothing to worry about right now. There's 10 years ahead of us as far as,
Yeah, but be
right?
ready. 10 years isn't very long. So become really good at what you do and really leverage AI to make you more productive. So that
Got it.
you're just like 10 people now because you mastered the AI techniques. You can
Hmm.
have it doing the work of 10 people for you and you're driving it. And then you're 10 times more valuable.
Okay. And yeah, that's a super insightful response. I appreciate that. And also closing remarks here. What's the number one thing that a gumbo listener should consider, especially if maybe they're in the market for a new database, right? Or they are trying to create another product and they want to tap into another database in order to embed that database within the new product. What do you recommend?
Well, of course, I'm going to recommend Faircom,
Yeah,
but
we know that,
but
right? We know that.
well, actually, to be honest, I would recommend the database that best meets your needs. But in general, you need a database that's going to give you the queryability of SQL because
Hmm.
SQL is well known, it's industry standard, and it can do everything you need to do to query your data. Until you get to the graph model, the graph technology, you need a graph model in your database so that you can answer questions that SQL cannot answer. For example, if you Google Maps will tell you the most efficient route to get from point A to B. SQL can't do that. Graph can. So you need to have SQL, you need to have Graph, and then the modern developer uses a technology called JSON. And
Hmm.
JSON is the most important, simple way to communicate with APIs. So you need a JSON database. So you need a JSON database that can work with SQL on the JSON data, work with Graph on the JSON data, and gives you those simple JSON APIs. And that's what Faircom database is. And so the graph, we're still improving the graph features, but we are super strong on the JSON and the SQL, and we have some unique graph technologies based on JavaScript.
Mm.
So more to come on that. In a
Okay.
future show, we can talk about our new cutting edge graph features that are different than all the other databases and actually bring graph to the masses so you can take advantage of it.
Awesome. Well, Mike, it's definitely been a pleasure to have you on Data Protection Gumbo. And before I let you go, I want to let all the Gumbo listeners know if you are not a member of our LinkedIn group, it's called Backup and Recovery Professionals, and there are over 26,000 members in that group. So we're having conversations similar to the ones that we're having right here on storage, backup and recovery, blockchain, databases, right? Cybersecurity, compliance, regulations, artificial intelligence, and the list goes on. So, Mike, once again, thank you so much for being a guest here on Data Protection Gumbo.
My pleasure completely. Thank you, Demetrius.